Hello students, in this video I am going to explain the concept of polynomials. In this chapter you have list of topics, a definition of a polynomial, what is the condition for not a polynomial, a degree of a polynomial, types of polynomial, two category, one is based on terms, another one is second one is based on degree, based on terms and based on degrees, number of terms, and the third sixth one is the value of a polynomial, seventh one is zeros of the polynomial, eighth one number of zeros of a polynomial. The complete basic concept about polynomial. This is foundation for class 9 and 10 standard mathematics. First, definition of a polynomial. An algebraic expression that can be written in the term of term or sum or difference of the term, either single term or sum of or difference of two or more terms. An algebraic expression that can be written as a term or sum or difference of the terms is called polynomial. An algebraic expression that can be written as a term, single term, or sum or difference of terms is called a polynomial. So for example, p of x equal to 2x cube minus 5x square minus 2x plus 5 is one of the example for polynomial. I will explain each and every word. Here if you come 5 into x power 0, here degree 0, degree 1, degree 2, degree 3. So highest power is 3 and hence that is called degree of a polynomial. So in this example, degree of a polynomial is 3 and the corresponding coefficient of highest degree is 2, that is called a leading coefficient. Leading coefficient. Leading coefficient is a coefficient corresponds to the highest degree, and this is cubic term, this is quadratic term, linear term, constant term. Degree 3 and hence it is cubic term, degree 2 quadratic term, degree 1 linear term, and 5 constant term. So this is one of the example for polynomial and the corresponding meaning of each and every words. Example, this is one of the example, degree 1, and this is example degree 2 because that is highest power. So here polynomial in one variable, this is polynomial in one variable, this is polynomial in two variables. Each term contains one variable with the whole exponents and real coefficients. So far we discussed a few examples in which the powers are whole number exponents, that is powers are whole numbers and coefficients are what? Real coefficients. A condition for not a polynomial. This is very important, useful for one mark question. Whole number exponents and real coefficients. Whole number exponents, these two are the condition for not a polynomial. Condition for not a polynomial. I'll give few examples. Not a polynomial, n of x equal to 2x square plus root x. Actually this root x nothing but x power half, which is not a whole number, because as per the condition the power is always a whole number. Right, maybe 0, 1, 2, 3 like that. Okay, so here power is half and hence not a polynomial. Next, second one, again it is not a polynomial. Here this is minus 2, power is minus 2, which is not a whole number, and hence second value, second expression is also not a polynomial. And third one, 8x square minus 2 by x, which can be written as 8x square minus 2 into x power minus 1. Again this power is negative number which is not a whole number, and hence third one is also not a polynomial. And the fourth one, n of x equal to 4 power x plus 3. Power is always a whole number, but in this case power is a variable. Power is a variable x. So in that power only whole number is allowed, but here instead of whole number here x is there, variable x is there, and hence it is not a polynomial. Last, n of x equal to 5 into x power 1 by 3 plus 3x square minus 2. 1 by 3 is not a whole number. So all the 5 examples are algebraic expressions are examples for not a polynomial because of negative powers, fractional power, negative powers, and instead of whole number here variable is there. So in your exam you can expect one question, if any one or two algebraic expression is given, identify whether it is a polynomial or not. To identify whether it is a polynomial or not, so you have to check two conditions. The coefficients are real coefficient. Almost all the coefficient will be real till 10th standard, but powers you have only one condition is allowed. The condition is power is a whole number, but here negative number is not allowed, fractions not allowed, and variables not allowed in the power. Okay, and next concept, degree of a polynomial. Degree of a polynomial, the greatest power to which the variable is raised. So here this is constant term degree is 0 and degree 1, degree 2. This is the greatest power and hence degree is 2. Here degree 1, 2, 3 and here the x power 0. So degree is 3. So here degree is 3. Based on degree you have one classification, and based on terms one more classification is there. Types of polynomial based on terms. Types of polynomial based on terms. Monomial means an expression which contains, or a polynomial which contains only one term. Either 6 or 4x cube or minus 5a square b cube. Either constant alone or constant into variable or constant into product of two variables. Here the condition is number of terms but not the power. Okay, so only one term, and hence these three are examples for monomial. So what is the definition of monomial? And polynomial which has only one term. And the second type, binomial, a polynomial which has two terms. So 6x plus 2, a b power 4 minus 5, y plus 2f. Here the condition is only two terms irrespective of the powers of the expression. Okay, and third type, trinomial, a polynomial with three terms. 3x square minus 5x plus 8, a cube plus 4y minus 7, and w by 2 minus 2s plus t. So irrespective of the power, all the three polynomial contains only three terms, and hence these three are called trinomials. And last type, a polynomial which has more than three terms. A polynomial which has more than three terms is called polynomial. An algebraic polynomial which has, or an algebraic expression which has more than three terms is called a polynomial. So this is first classification of polynomial based on number of terms. Based on, for one term it is called a monomial, for two terms it is called binomial, for three terms it is called trinomial, more than three terms polynomial. Second classification based on degree, constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial. Constant polynomial is polynomial of degree 0, all constants, for example 2, 3, 5, all are constants that can be written as 2 equal to 2 into x power 0, and hence all numbers are called constant polynomials. Second one is linear polynomial, a polynomial of degree 1, x plus 2, y plus 5, okay, 3u plus 4 or 7y. Here in previous type, the classification based on number of terms, here the classification based on powers. So here these three contains two terms, but this contains only one term. Even though it contains one term, this is called linear because degree. Here constraint is based only on the power, not on the number of terms. And general form of this is ax plus b, where a not equal to 0. This is condition for general form of a linear polynomial. And third type, quadratic polynomial, a polynomial of degree 2, 2x square plus 5, x square, actually this is 2 by 7 into x, and 5x square plus 2x plus 5, or 7x square. One term, two terms, three terms. Okay, so irrespective of the terms, the degree of each and every polynomial is 2, and hence all are examples for quadratic polynomials. So examples, general form of quadratic, ax square plus bx plus c, where a not equal to 0. This is condition for quadratic polynomial. And a cubic polynomial, a polynomial of degree 3, is called the cubic polynomial. 8x cube 2x cube plus x plus 1, 6 minus x cube. So irrespective of number of terms, here the degree of each and every polynomial is 3, and hence these are all examples for cubic polynomial. And general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a not equal to 0. So far we discussed two classification of polynomial. The first classification based on number of terms, and second classification based on degree of the polynomial. Now these are all the detailed explanation of linear polynomial. Ax plus b where a not equal to 0. When a equal to 0, why this condition? When a equal to 0, it is a constant polynomial. So for linear polynomial, compulsory the coefficient of first degree term is always non-zero. That is the condition for this. So 2x minus 3y plus 2, 3z plus 4, 7y, all are examples for linear polynomial. Quadratic polynomial ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. If a equal to 0, it becomes linear polynomial, and hence the coefficient of highest power is always non-zero. That is coefficient of second power is not equal to 0. And a cubic polynomial, a polynomial of degree 3 is called a cubic polynomial, and general form is ax cube plus bx square plus cx plus d, where all the four coefficients a, b, c, d are real numbers and a not equal to 0. Here the examples are x cube plus x square plus 2x plus 3, coefficient is 1, suppose this is 7x cube plus x square. But condition is the degree of cubic third power is always not equal to 0. Now sixth concept, value of a polynomial. If p of x is a polynomial in x, and k is any real number, then the value obtained by replacing x by k, replace x by k in p of x is called value of a polynomial at x equal to k, and is denoted by p of k. Simply p of x equal to x square minus 5x plus 6. If I want to substitute find p of value of p of 1, replace x by 1 square minus 5 into 1 plus 6, which is equal to 1 minus 5 plus 6. 6 plus 1, 7 minus 5, 2. Here the value of a polynomial is 2. Another very important one mark question, find the value of a polynomial. And the second one, p of 2, find the value of 2. Value of the polynomial at x equal to 2. Again replace x by 2. So 2 whole square 5 into 2 plus 6. 2 square minus 5 into 2 plus 6, which is equal to 4 minus 10 plus 6. 6 plus 4, 10 minus 10, 0. Here the final value is 2, but here the final value is 0. Again 0 is the value of this polynomial at x equal to 2. Whenever the value is 0, we have one more additional concept. That concept is called 0 of the polynomial. Suppose if the value of the polynomial is 0, then it is 0 of the polynomial or root of the polynomial p of x. Next concept, zeros of the polynomial. A real number k is said to be 0 of a polynomial if p of k equal to 0. See here, here p of 2 equal to 0, then x equal to 2 is a 0, because the value of a polynomial is 0. That is the next concept, p of k equal to 0. The zeros of polynomial p of x are precisely the x coordinate of the points where the graph intersects the x axis. That is the graphical meaning of the polynomial. The given polynomial p of x equal to x square minus 5x plus 6, p of 2 equal to 2 square minus 5 into 2 plus 6, which is equal to 4 minus 10 plus 6, which is equal to 0, and hence x equal to 2 is 0 of the polynomial. And next one, verify whether 3 is a polynomial or not. If you substitute, if you replace x by 3, 3 square minus 5 into 3 plus 6, which is equal to 9 minus 15 plus 6, yes, 0. Both are zeros of the polynomial. But how to find zeros without trial and error method? Because it is a quadratic polynomial, you can apply your lower class concept, splitting the middle term, because it is a quadratic polynomial. What is sum? Sum is nothing but sum product Okay, sum is nothing but coefficient of x. Here the coefficient of x is minus 5 and product is nothing but coefficient of x square into constant term, which is equal to 6. Factorize this so that its product is 6 and sum is minus 2. Factorize 6 so that its sum is minus 5 and product is 6. Here the factors are minus 2, minus 3. Minus 2 into minus 3 plus 6 and its sum is minus 5. Therefore, you can write this as x minus 2 into x minus 3, and if equal to 0, x equal to 2 and x equal to 3. Yes, these two are the zeros of the polynomial and hence its value of the polynomial is 0. So, value of the polynomial. Last, number of zeros of a polynomial. A quadratic polynomial can have at most 2 zeros. A cubic polynomial can have at most 3 zeros. A polynomial of degree n has at most n 0. Why at most? In your higher studies you can find a polynomial which has a complex 0 or imaginary zeros. So this is what in terms of real for example cubic polynomial, for example x square minus 1, this is quadratic, it has 2 zeros. This is x square minus 1 equal to 0, x square equal to 1, x equal to plus or minus 1. Whereas x cube minus 1 equal to 0, x cube equal to 1. Okay. Otherwise, if you factorize this polynomial formula, x minus 1, x square plus x plus 1 equal to 0. 0 of this expression is 1 and it has imaginary zeros. But totally degree is 3, it has 3 zeros, but one 0 is x equal to 1 is 1 0 and other 2 zeros are imaginary zeros. Totally 1 plus 2 3 zeros, but number of real zeros is only 1. So total number of zeros is at most, that is the reason for at most, and linear polynomial has only 1 0. Okay. So far we discussed in-depth concept about polynomial. Again I will revise the concept. What is the definition of a polynomial? What is the condition for not a polynomial? What is the definition of degree of a polynomial? Types of polynomial based on number of terms, types of polynomial based on degree, and value of a polynomial, zeros of a polynomial, number of zeros of a polynomial. These 8 concepts are very important in polynomials concept. Thank you.